this is chapter 6, so I'm not just, but I want to talk to you through, and you can sort of figure out it conceptually. All right. So when he's standing on the ground before he fires the rocket, he's standing on the ground, and his speed is 0, so he's got a certain amount of energy. What should we call it? Well, what? All right. Here we go. So here he is on the ground. All right. All right, and there he is. He's Rocket Man. He's on the ground. What's a convenient place to label as height equals 0? The ground. All right. So here's h equals 0. All right. So now he's at h equals 0. He's standing still. So what's his kinetic energy? 0. What's his potential energy? 0. So he's got 0 energy. And then we've got a certain amount of work that gets done by the pack. And then later on, he's up in the air. It says it's straight up, so this is going to have to be a time factor here. So let's just take this guy. Oh, really? All right. So we'll ungroup him so we can copy him. All right, just you, buddy. All right, come on up. Come on up. All right. So, aha, there he is. Before and after. So now afterward. Yeah, that's all right, but this is time in this direction too. All right, so he's got a velocity is equal to 5 meters per second. Does it matter if it's straight up or sideways or whatever? No, does it? No, because it's a scalar, right? We know that energy is a scalar, so it doesn't matter what the direction is. So we could say speed. All right, so now also he's got a new height, which is 16 meters, I think, right? 16 meters. And he's got a speed. So are only conservative forces working? Or are there any non-conservative forces working? The propulsion is non-conservative, right? But we also have gravity. All right, so now we have a certain amount of energy at the bottom, our energy budget, but actually our budget changes because we have income. What is the income, analogously, sort of metaphorically? What's the income? How about not energy produced, but along those lines? How about the work done by? The work done by the propulsion unit, right? So that increases the amount of change we have in our pocket. That increases the amount of the energy we have in our system. All right? So we know that kinetic energy plus potential energy plus the work done by non-conservative forces, this is kinetic energy naught, potential energy naught, plus work done by non-conservative forces is going to be equal to kinetic energy plus potential energy at the end. Right? This is our initial amount of energy. This is our income. This is our final amount of energy. Does that make sense? Okay. So now all we have to do is say, we're trying to solve for the work done by the non-conservative force, right? Where does it say that? The work done by the force generated by the propulsion unit. And we've said it's a non-conservative force. So now if we just solve for non-conservative force, we'll be able to get what our answer is. All right? So this is 0 right here. So that's really easy. All we have to do is add up the total amounts of energy he has, both kinetic energy and gravitational potential energy at the end. So the work done by non-conservative forces is equal to his kinetic energy at the top, 1/2 mv squared, plus his potential energy at the top. What's his potential energy? mgh. Easy, because we started at h equals 0. All right? So mgh. So now we just got to have to plug in our numbers and get the calculator brigade going. 1/2. Let's get m out of there, because that's easy. So m times v squared over 2 plus gh. All right, so mass is, that was 136, correct? 136 kilograms. All right, and what is v? 5 meters per second, right? 5 meters per second. We got to square that over 2 plus g, 9.8 meters per second squared, times 16 meters. Thank you. 16 meters. And got another close there. And so that's going to be, calculator people. Wait, before we do the calculation, what are we going to do? The green pen. Yes, dimensional analysis. All right, we got meters squared per second squared. We got meters squared per second squared. So we're going to have kilogram meter squared per second squared. Spencer, what's that? Kilogram meter squared per second squared. Close. It's It's energy. It's joules. Right. All right. All right. So now the work done by this non-conservative force, the propulsion unit, is calculator people. What do we got? 23,000 0 24.8 joules. So is that really a reasonable amount of precision?
Sure.
I don't think so. I'm not going to be real crazy about sig figs, but what do we have as our initial information? We got 2 sig figs, 2 sig figs, 3 sig figs, so we should go with 2, right? So how about 2.3 times 10 to the 4th joules? All right, there we have it.